Hey guys, James here. Today I'm making another video about a very interesting, I made like 2, 3, 4 videos about it, about a very interesting entity that looks like this. So it's all about this thing here. It's an entity, it's a different kind of entity. Like you are an entity which called human. Then we have another entity called animals. Then we have another entity called plants. So these are all entities. So it's all about this, or it looks like this, or it looks like this. Doesn't matter. Or it looks like this. So what is so magical about that thing? Some people call it the line to measure. Some people call it the I, the ego, the I. Some people see it as a wire. So it has different meaning, but all three function in the same way. It doesn't matter how you bend the line, you know. It can be like this. Sometimes you see the line like this. Hold on. Let me do a little bit better. So what is this magic about this line right here? Right? For measuring, you can see it as the eye, you can see it as a wire. You see it sometimes bended or folded in, or the other way around, or this way. Sometimes you see it this, like you see it as a form like this, or like this, or you see that thing. So, or you see that thing that looks like this, right? So that line right here, this magical line, can deform and can be in many ways folded or bended in any direction, as you see here, right? It's the same thing. It's all the same thing, right? It's all the same thing. Doesn't matter. It's always this one line. The essence of all these things is that it's all this one single line, right? So now you have to, when you figure out and experience what you can do with a single line, right? Like we see it on here. It can bend in different ways. It can bite in its own tail, etc. So these are all things that this one single line can do, or the wire can do, or the human eye can do. So that line right here, right, is a measure thing. So these are all the varieties what it can do, but it's all the same thing. But when we do these other things with the same with the same material, right, we have to make a difference, right, to see it the other way then. So we have to give it names, right? Like 180 degrees, right? Horizontal or vertical, it doesn't matter. 180 degrees, right? So now comes numbers in place. See, that's the thing where I'm getting at. We have to make a difference to see the difference between this and that, because if there wouldn't be the number, it would be look all the same thing, right? It would be all look this magical line. So we give it numbers. So we say this is 180 degrees. If we see it like this, then we call it 90 degrees. I'll just make I don't write it fully out. You know, this sign means degrees, right? So this means 360 degrees. So we separating it, that line, by numbers, right? But all it is, it's still all 180 degrees. And I'm going to show you. Then we can make also this. It's 45 degrees, but it's all that. The differences between these things are just the numbers, right? Like, look, this is a 90 degree, right? Because one side is 90 and the other side is 90, which is 180. If you pulled it back up, it's 180. So it's actually a 180 bent over to be 90. So it's on each side is 90. 90 and 90 is 180. Same thing with now we reduce it down from 180 to 90 and reduce it a little bit more down from 90 to 45. 45 means nothing else than there are two 45s, which is this side is 45 and this side. This side is 45 and this is 45, which is 90. So it's always zooming in, going down in the smaller particle, right? So 180 is this, it's 90 and 90, it's bending over, it's folded in, but if you fold it back, it's 180. It's anyway also 180, even if it's like this. The same thing with here. It's also 180. It's just the numbers that makes the differences. That tries to create you illusion of geometrical observations. But it's all 180. It's all this. It's all this. It's just like they make it just difference because of the numbers. So 180 is all of them is 180. They just are folded or bowed in one direction or in a smaller folding degree. So these are all 180s. The differences is just we give the differences by putting numbers on it. So this is 180. This is 90 because it's folded in. So this is 90 and this is 90, which is 180. Right? But the 90 will focus on the inside. And then you go more smaller from the 90, which is 45 degrees, which is the same thing. One side is here 45 and one side is here 45, which is 90, right? So it goes like, actually like, whoop. This goes whoop. So if you fold it 45 degrees up, it's 90 and it's 60. So it's actually like, if we put it on a scale. So you see now the difference between 180, 90, and 45. So this is 180, but it's all the same thing. That's the thing. That's what makes people only confusing are those numbers. But it's all about one line. And the magic about a line, you can bend it in all directions and forms. I come to the 360 in a minute. So this is then actually this 180. Now we go smaller down, which is the 90, which is this, and then 45, which is this. But when you fold everything up, then this becomes, they are all 180, But if we go from the scale to scale, you fold it up, this becomes 90, this becomes 180. The 360, which is a round circle, is also 180, just stretched, right? Biting in its own tail. And it says 180 and 180. Maybe let me draw it on the other side so you can see it better. Oh, I got it right here. And here the 360. And the 360 is also two parallel 180, so to speak, look into each other, because it's biting its own tail. It's one stretch, because a 360 is just an open 180, meaning this is 180 and this is 180. It's together 360, but stretched out, right? It's biting in its own tail. And and you can put the 45 degree in it, you can put the 90 degree in it, and you can and the 100. So it's all about scaling. It's all about from small, tiny, small, mid, and then large. That's all about. That's what it's all about in geometry. Making everything smaller or bigger, and then making a difference out of it. It's actually like trying to confusing your optics. Another thing is the squares I did, remember? Like the same thing with the square. It's one thing, but the difference makes it, when you make it, when you form it in a different form, it gives you the feeling of a differences of but it's all the same. Let's say, for instance, here the square right here is also one line. It's one line. It's just like it has corners, but it's one single line. And the difference is only when we add numbers on it, right? That's what it's just confusing, which is really actually not necessary. So this is a square, right? So let's say this square is 4 centimeters, right? 4, 4, 4, 4. Now, if we tip the half of it, which is 2, and we draw the 2 inside, 2, 2, 2, 2, and outside is 4, 4, 4, and between the outer space and the inner space is 1 centimeter. So you can do it like this. You can move this around in any corners, it doesn't matter. Then it looks like this. Let's move it down here. Or we move it up here, or we move it up there, or we move it up down here. Doesn't matter. Let me place it all in it. It's all the same thing. It's all about, as before with the 180, the line, it's all about scaling down and scaling up, and the differences. So all these are 2, 2, 2, 2. So it's all, you can take even those 4 out, right? And it's the same thing if you put those together like this. The same numbers, the same. It's all the same. You can take this and twist it around a little bit by doing this. But it's all the same thing which is given here, right? This is 4, 4, 4 square, right? This is, and we said this is 2, right? 2, 2, 2, no, 2, 1, 2, doesn't matter. Then we can put it down here. Then it's here, then it's filled out this area. Or we can put it up there, which is then over here. Or we can put it to the left, which is then here. Or we put it down, which is then this one. But if you put all 4 in, it will be filled out completely like it's one thing. So this is geometry. Geometry is playing optical illusions and perceptions in your daily life, but it's all the same and the one thing. And this is how then mathematics, it's like first it is I would say first of all, it's the nothingness. I did a previous 2-3 videos about it, nothingness. And then comes the understanding, minimalistic understanding. That's my new term, minimalistic understanding. And then comes geometry. And then after geometry comes mathematics. And mathematics is there to give geometry objects, forms, a value, and then you make the equations with mathematics. So so this is the highest. Number one, and then it comes here, and it comes this, and I would say it comes this. So it's going, the process goes from this, goes down this way, right? So this is, because minimalistic understanding is between, I said it before, it's between invisible and visible. And geometry is the expression, or is the gate that expresses the invisible understanding to understanding the nothingness dimension, which is in the invisible, is using geometry. It needs geometry to mutate or to transform, or to mutate or transform in our dimension, which we see then it's geometry, like those forms and here and etc. and square and etc. And then we give to those forms mathematical values, or we give it a color, or we give it a name, or we give it a mathematics values, numbers. And these are the differences. These are sequences and frequencies. Numbers is not how can I say? Look, numbers are actually just sequences, just frequencies. Like when I do this, look, now listen to this. What you perceive is this, look. Boop. 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 Now, as you from listening, you count 1, 2, 3. But when I do this, boop, 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 I did it faster, and it sounded as 1. And why? Because I did it faster. So I hope you understand that thing. Thank you for watching. See you next time, and stay with me to see incredible things. Bye.